In this class, now I would like to teach you the complete concept of system of circles. In this system of circles, there we have four objectives. The first one of these four objectives is angle between the two circles, and the second one is radical axis of two circles and its properties, and the third one is radical center of three circles and its properties, and the fourth one is length of common chord of two circles. Now let us discuss one by one of these four objectives. Now the first one is angle between two circles. See here, I am going to find angle between two circles. Let us consider two circle equations. The first one is s is equal to x square plus y square plus 2gx plus 2fy plus c is equal to 0, and the second one is s dash, which is equal to x square plus y square 2g dash x plus 2f dash y plus c dash equal to 0. Now draw the figures of these two circles. Let us name the first circle is s equal to 0 and the second one is s dash equal to 0. You know, students, angle between the circles is possible if and only for the intersecting circles. You know the relative positions of two circles on the plane. Whenever the circles intersects each other, then only angle between the two circles is possible. Now here I have drawn two circles, so which are intersected at two places. So let us name the two point of intersections as A and B. Now draw the tangents to both circles at whose point of intersections. So here, come to here, and this is one of the point of intersection. Draw there one tangent. This tangent will move like this. So this is the tangent which is drawn to the first circle at this point of intersection, and go to the second circle, and for which also draw one tangent at this point of intersection. You will get like this. Angle between these tangents is equal to the angle between the circles. I hope you have got it. Angle between these tangents is equal to the angle between the circles. So now I am going to find angle between these two tangents. So before going to find angle between these two tangents, so let us assume the center of first circle is C1, center of second circle is C2. Now connect this C1 and C2. See, this tangent is intersecting this line joining of centers C1, C2 at one point. Let us name this point is T2. And this tangent is intersecting C1, C2 at this point. Let us name this point as T1. Now you know, see, this is the radius C1A, and C2A is the radius of second circle. Let us name the radius of first circle be R1, radius of second circle be R2. See, and also assume angle between these tangents. In this figure T1A, T2. Let us consider T angle T1A, T2 be theta, which we have to determine. Okay students, right. Now see here I am measuring angle C1A, C2. This is different than this. Observe carefully. What is this? Angle between the tangents which are drawn at this point of intersection for both circles. But here one triangle A, C1, C2 is formed. So in this triangle A, C1, C2, this is vertical angle. So this vertical angle I am measuring here. See how I am measuring. So you know students, this radius makes 90 degrees to this tangent at its point of contact. So in that figure, that is C1A, T2. This is the radius R1, which makes 90 degrees angle with this tangent at this point of contact. You know that angle between the radius and tangent is equal to 90 degrees at its point of contact. So in this figure C1A, T2 is equal to 90 degrees plus next C2A means that is radius of second circle, which makes 90 degrees with this tangent. In that figure C2A, T1, this is also 90 degrees. 90 plus 90. Observe carefully students, while measuring this angle C1A, T2, so this theta, this is the theta, angle between the tangent, which is included in this 90 degrees. This theta is some part. So while measuring C2A, T1 also, this theta is included. This theta is included in this also. But we need to consider only one time. So that one time this angle between the tangents here I am subtracting. So which is equal to theta. What is my aim here? I want this vertical angle in this C1A, C2 triangle. To find this C1A, C2, which means that vertical angle of this triangle. So to measure this angle, what did I do? I took this 90 degrees. And next I took this 90 degrees. So in both this theta is some part. But I want to consider only one time. So 2 times here included. So that I am subtracting 1 time. You know here added means here theta is included 2 times. But I want to consider only 1 time now. So that 1 time I have subtracted. You know that principle of inclusion and exclusion. So same principle here I followed. I got angle C1A, C2, which is equal to 180 degrees minus theta. Right. In the next step, I am going to apply cosine rule at this vertex A. I got this vertical angle as 180 degrees minus theta. So with respect to that 180 minus theta, now I would like to apply cosine rule. You know that cosine rule which you learnt in the properties of triangles. See, ABC is a triangle in which length of BC is small a, length of AC is small b, length of AB small c. Now apply cosine rule at this vertex. So what is that formula? B square plus C square minus A square by 2BC. You read this formula. So similarly you can write cos B cos C also. So same that cosine rule I am going to apply for this vertical angle. So here whose adjacent sides are r1 square plus r2 square minus opposite side square. With respect to this vertical angle, opposite side is c1, c2. Let us name whose length is d. Distance between their centers is d. Now write that d square by 2r1 r2. You know students, cos of 180 minus theta is equal to minus cos theta. Now from the numerator take minus common. So inside you will get d square minus r1 square minus r2 square by 2r1 r2. Now cancel these two minuses. So what you have got? Therefore cos theta is equal to d square minus r1 square minus r2 square whole by 2r1 r2. So this formula we use to find angle between the two circles. Cos theta is equal to d square minus r1 square minus r2 square by 2r1 r2, where theta is the angle between the circles and d is the distance between their centers. R1 r2 are radii of both circles. I hope you have understood this formula derivation. So instead of preparing this d, r1, r2 and substituting over there, so we have one more direct formula. Even that one also we derive from this formula only. See, this is a first circle, you know, s equal to 0, whose equation x square plus y square plus 2gx plus 2fy plus c equal to 0. Now find whose center, that is c1 in this figure. So you get minus g minus f. Similarly find the center of second circle, minus g dash comma minus f dash. Now find the distance between both, so that you will get here d, square root of, so difference of x coordinates, minus g dash plus g whole square plus minus f dash plus f whole square. You got d. In the same manner prepare r1. So r1 is equal to, you know that, g square plus f square minus c, r2 square root of g dash square plus f dash square minus c dash. Now substitute all of them in this formula and go for simplification. See here, cos theta is equal to d square. Now square on both sides. So that here what do you get? Minus g dash plus g, or otherwise write like this, g minus g dash whole square plus f minus f dash whole square. D square, take square on both sides and write here, minus r1 square. What is r1? This one, no? Now whose square is equal to g square plus f square minus c minus r2 square, g dash square plus f dash square minus c dash whole by 2r1 r2, root of g square plus f square minus c into root of g dash square plus f dash square minus c dash. Now simplify the numerator. If you simplify the numerator, we get cos theta is equal to, expand it, a minus b whole square, a square plus b square minus 2ab. So this one also, second one, f square plus f dash square minus 2ff dash. Now before both brackets minus sign is there, open it, you will get g square minus f square plus c minus g dash square minus f dash square plus c dash whole by 2 into root of g square plus f square minus c into root of g dash square plus f dash square minus c dash. Now simplify that. On simplifying this, we get, see here, plus g square minus g square can be cancelled, and plus g dash square, here minus g dash square, plus f square minus f square, plus f dash square minus f dash square cancel. Still any more like terms can be cancelled? No one. So write the leftover terms, c plus c dash. So here minus 2gg dash minus 2ff dash. From both take minus 2 common. Inside you will get gg dash plus ff dash whole by 2 into root of g square plus f square minus c into root of g dash square plus f dash square minus c dash. So directly you people can utilize this formula also to find angle between the two circles. Collect that G, F, C and G dash, F dash, C dash from the two given circles and substitute in this formula and go for simplification, so that you will get your required angle between the two circles. And also students, suppose if angle between the two circles is 90 degrees. You know, if angle between the curves is 90 degrees, then such curves are called orthogonal curves. You know that. So in the same manner, if angle between the circles is 90 degrees, then such circles will be called as orthogonal circles. So if theta is equal to 90 degrees, then such circles are called orthogonal circles. So for the orthogonal circles, so here put theta is equal to 90 degrees here. You know, cos 90, 0. Now bring this denominator to the left side, so that you will get 0 into something, 0. Here we are writing theta equal to 90, then cos 90, 0. Now bring it to the left side, 0 into something which becomes 0. So now transfer this one to the left side, so that you will get 2 into gg dash plus ff dash, which is equal to c plus c dash. This is the condition for orthogonal circles. I hope you have understood how this relation is generated. So from this formula only we get. So for the from the previous formula, so we read one more formula to find angle between the circles. Cos theta is equal to d square minus r1 square minus r2 square by 2 r1 r2. If theta is 90, cos 90 0. Bring it to the left side and simplify. You will get d square, which is equal to r1 square plus r2 square. So that is also one more relation for orthogonal circles. I hope you have understood this. So suppose if radii of two circles are equal, if radii of two circles are equal, then see students, okay, circles are orthogonal circles only, and along with this orthogonal circles, see, if radii of two circles are equal, automatically angle between the two circles will be 90 degrees. If you want, so you can check it. See, draw the tangent through this point of intersection which passes through the center of second circle, and draw the tangent to the second circle at its point of contact which passes through the center of first circle. In the previous diagram, the two tangents were not passes through the centers of two circles, but in this case, whenever radii of two circles is same, then the tangents which are drawn at this point of intersection are passes through the centers of two circles. Hence angle between them is 90 degrees. If angle between them is 90 degrees, then which will be called orthogonal circles. So you know, for orthogonal circles theta 90. If you write here theta 90, then it will become cos 90 degrees, which is equal to d square, and r1 r2 both are equal. Let us say that equal radius is r. R square minus r square by 2r into r. Now cos 90 0, bring it to the left side. Now d square, which is equal to 2r square, you will get. Now if you want to make r as subject, now r square is equal to d square by 2. Now transfer square to the right side so that you will get d by root 2. Remember this. When do you get a radii of that circles is equal to d by root 2? Whenever their radii must be equal, and okay, if the radii are equal, automatically which are called orthogonal circles. So for orthogonal circles, not for all orthogonal circles, only whenever their radii are equal, automatically which will be called orthogonal circles. So for such kind of circles, r equal to d by root 2. You know where r is the radius of that circle and d is the distance between their centers. This is the first objective of this system of circles. Now let us go to the second objective, that is radical axis of two circles and its properties. You know students, see here, radical axis and its properties. See the definition of radical axis. Consider two circles. One is s equal to 0 and one more is s dash is equal to 0. Now, see, consider this locus. See the definition of radical axis. This radical axis is one kind of locus. So from this locus, if you take any point, let us take x1, y1. x1, y1. If you measure powers of this point with respect to these two circles, which will be equal? The locus of a point which moves such that its powers with respect to these two circles are equal is a line. That line is called a radical axis. This is the definition of a radical axis. The locus of a point which moves such that its powers from that locus to these two circles are equal is a one line. That line is called a radical axis. See here, this locus is called radical axis. As per the definition, if you take any point on this locus and measure whose power, you know how to measure power of a point with respect to the circle. So you have one formula to find power of a point with respect to the circle, that is S11. You know that notation. And with respect to this circle also measure it. You will get S11 dash. Both will be equal. Both will be equal. So see, S11 is equal to S11 dash. You know students, S11 is nothing but x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Now which is equal to, what is S11 dash? For the second circle power, So x1 square plus y1 square plus 2g dash x1 plus 2f dash y1 plus c dash. So now x1 square cancel, y1 square cancel. Now bring these three terms to the left side so that you will get 2 into g minus g dash x1 plus 2 into f minus f1 y1 plus c minus c dash, which is equal to 0. Now this is the equation of this locus. Okay, so you know in the locus, so in the final answer we must replace x1 y1 by xy, so that you will get 2 into gg dash x plus 2 into f minus f1 into y plus c minus c dash, which is equal to 0. So this is the equation of this radical axis. I hope you have understood this radical axis definition. See, this is the locus. If you take any point on this locus and measure its powers with respect to both circles, which will be equal. So I have equated, and in the final answer I replaced x1 y1 by xy. I got one linear equation in two variable, which represents this equation. And you people can able to define in one more way. See, this point P is there outside. Now measure the length of tangent from this outside point to these two circles, that is root s11, root s11. So which will be equal in their length. Take this point anywhere on this dotted line. We are saying this dotted line as radical axis. So if you take this P anywhere and measure the lengths of tangents to these two circles, so whose lengths will be equal? Okay students, so if the point P is there outside, then only tangent can be drawn from exterior point to the circle. If the point is P is there inside, so tangent is not possible. So that the exact definition is its powers with respect to the two circles are equal. That definition you must learn. Okay students, I hope you have understood the meaning of a radical axis of two circles. The two circles may be non-intersecting, or may be touches, or may not be touches. We have 6 relative positions of two circles. So let us discuss a radical axis of that relative positions of circles. So this is the radical axis for non-intersecting circles. Okay students, I hope you have got it. Now let us go to learn properties of this radical axis. Properties of radical axis. AXIS, axis is a singular, AXES, axis is a plural word. Right students? See, suppose if the circles are intersecting at two points A and B. Now this is the common chord, no? This common chord will be the radical axis for two intersecting circles. Then whose equation is s minus s dash equal to 0 only. In the previous one, that right side of equal terms I brought to the left side, no? So which means that simply we applied there s minus s dash equal to 0. If you apply s minus s dash equal to 0, s equal to 0 is the equation of first circle, s dash equal to 0 is the equation of second circle. If you take the difference of these two, you will get equation of that radical axis. But for these intersecting circles, this common chord, this is a chord for the first circle as well as second circle. So this common chord will be the radical axis for those two circles, intersecting circles. And remember one more point, if you connect their centers, you will get a line segment, na? That line segment is, this is a C1, C2 line segment which is formed by connecting their centers. That line will be perpendicular to the radical axis. This is very, very important point. Remember it. Okay. So this C1, C2 is perpendicular to radical axis. And also the C1, C2 bisects this common chord. So this portion we are saying it as common chord. So let us take this point P is the point of intersection of C1, C2 and radical axis. Then C1, C2 bisects this common chord, that is PA equal to PB. Okay, students? Right. So now let us go to learn radical axis of touching circles. Two circles may touches externally or two circles may touches internally. So for this touching circles, so this is the common tangent. This common tangent will be the radical axis. S equal to 0, S dash equal to 0. Now radical axis equation is S minus S dash equal to 0. Here also S minus S dash equal to 0. Okay, students? Right. Next, see this. If one circle is completely lies in other, in this case your radical axis will be outside of the circle. S minus S dash equal to 0. And the last one for concentric circles. For this concentric circles, radical axis does not exist. And see students, one more point from this radical axis. See here, two circles are there. Now connect this A and B. Then AB will be called common tangent. You know this. Either it may be direct common tangent or you can take transverse common tangent. So for these two circles, this is called what? Radical axis. Okay. So this radical axis bisects this common tangent. That is PA equal to PB. Radical axis bisects means which divides into two equal parts. This radical axis bisects this common chord PA equal to PB. Even this is a direct common tangent. No, you can take transverse common tangent also. Let it be CD. Connect these two. So this is called Q, point of intersection of radical axis and this transverse common tangent. Even you can write CQ is equal to QD also. Okay, students, these are the properties of radical axis. Now let us go to learn third objective of this chapter, that is a radical center of three or more than three circles and its properties. See students, draw radical center. Draw three non-intersecting circles. So this is the radical axis for these two circles. Now draw the radical axis of these two circles. Draw the radical axis of these two circles. These three radical axes are concurrent at one point. Let us say this point as P. This point of concurrency of radical axis of these three circles is known as radical center. So here I have taken three circles. I got three radical axes. If I take n circles, then number of radical axes will be nc2. Here I took 3. So here 3c2. Now simplify this. 3 into 2 by 2 into 1. 2 cancel 3. I got 3 radical axes which met at one point. That meeting point is known as a radical center. Now let us learn whose properties. Properties of radical center. See students, this is the radical center. Now from this radical center to draw tangent. Okay, from P to these three circles, draw tangents. See, PA is the tangent drawn to the first circle. If you want to draw the tangent to the second circle, that is PB. And for the third circle, PC. These three will be equal in their length. PA equal to PB equal to PC. If you draw the three tangents from radical center to these three different circles, then whose lengths will be equal? PA equal to PB equal to PC. Next, see students, three circles and whose radical center is P. This is a tangent drawn from radical center to the first circle. Now I am drawing a circle. PA as radius and P as centers. Take this PA as radius and draw a circle with center P. We got one dotted circle now. So that intersects these three given circles orthogonally. Here what did I do? I have drawn a circle, dotted circle of radius PA. PA is tangent, length of tangent drawn from radical center to the first circle. Now draw a dotted circle of radius PA and with center P. So which intersect the three given circles orthogonally. Remember this point. Next, see here students, see, I am taking three intersecting circles. Let us name this point A and this is B. Now connect this AB and this is C. Connect this AC and connect BC. Here one triangle ABC is formed. So you know this triangle has three sides, AB, BC, CA. Observe carefully. This is the circle which is described on this ABC triangle as AB as diameter. How these three circles are described on the sides of ABC triangles as this AB, BC, CA are diameters of these three circles. Suppose if you observe this circle. So AB is the diameter for this circle. Now see this circle. For this circle BC is diameter. For the third circle AC is the diameter. So these three circles are described on this triangle ABC as whose sides as diameters. Now the orthocenter of this triangle ABC is the radical center of these three circles. Have you got my point? If the three circles are described on the triangle ABC as whose sides has diameters, then the orthocenter of triangle ABC will be the radical center of the three circles. You know the meaning of orthocenter of a triangle. ABC is a triangle. Now draw the altitudes. Okay. Three altitudes are possible. The three altitudes are concurrent at one point, that is called orthocenter, which is denoted by either O or H. You know the location of orthocenter also. For acute angle triangle you will get inside. For right angle triangle you will get the orthocenter of this triangle at the vertex where the right angle is located. This is the position of orthocenter for this right angle triangle. For obtuse angle triangle you will get outside. This side you will get orthocenter. I hope you have got it right. Understood this point? So if the three circles are described on the triangle ABC as whose sides has the diameters, then orthocenter of triangle ABC will be the radical center of three circles. You may ask me how, sir? See, students, let us take center of first circle is C1, center of second circle is C2. Okay? See here, this is diameter, no? You would have to take that center here, C1, here C2, and here you have to take C3. Now if you connect C1, C2, see, you got the diagram like this. This is C1, C2. This is the midpoint for this AB and this is the midpoint for this AC. Hence C1, C2 is a line segment which is connected by joining the midpoints of AB and AC. Then you know that midpoint theorem of the triangles. The C1, C2 will be the parallel to BC. Now this is what? An altitude. Okay, your altitude is drawn from A to C1, C2. Here this altitude is perpendicular to C1, C2. Obviously it is also perpendicular to BC also. If it is perpendicular to C1, C2, then automatically this altitude will be perpendicular to this BC also, because C1, C2 and BC both are parallel to each other, no? So here also, see here, if you want to draw, you can draw like this. What is this actually? Common chord of these two circles. As you know, this common chord is called what? Radical axis. And also here it is altitude from A to BC. Means that altitude and radical axis both are coincident in the same manner. So see students, connect C1, C3 and draw here. So if you draw, you will get, see, you will get altitude from B to AC. Even this is common chord for these two circles. So this common chord and radical axis. Okay, so here this is altitude and radical axis both are coincident. In the same manner, from C to C, this is common chord as well as an altitude drawn from C to AB. So these three are concurrent at this point. That is called orthocenter of triangle ABC and radical center of three circles. Have you got this point? I hope you have understood it. Now let us go to one more point. See, there are three circles which are intersecting. Okay, there are three circles which are intersecting orthogonally. Let us name whose centers as ABC. So now connect to this ABC. You got a triangle ABC, no? Then whose orthocenter and a radical axis, whose orthocenter of ABC triangle and a radical center of these three circles are same like previous one. What kind of circles are these? Which are orthogonal circles. So for this orthogonal circles, ABC are centers, and I have connected that centers. I got a triangle ABC whose orthocenter is the radical center of these three circles, same like previous one. Draw the common chords. That common chords will be the altitudes for ABC triangle, and that common chords and altitudes both will concurrent at same point P. Hence, orthocenter of the triangle ABC is the radical center of three circles. Now let us go to one more point. If three circles touches externally, now assume whose centers as ABC. Now connect to this centers. You got a triangle ABC. So for this three circles you will get radical center at here. Now this radical center is the incenter of this triangle ABC. What is radical center here? Incenter of this triangle ABC. You know, incenter. So draw the interior angle bisectors. Interior angle bisectors. These three interior angle bisectors are concurrent at one point. That point of concurrency is known as incenter. Incenter is equidistant from all the sides. Take a radius from incenter to any one side and draw one circle. That is called incircle whose radius is smaller. You know that. Okay. So here, this is radical axis of these two, and if you extend it, this will be the angle bisector for this angle. In the same manner, see, this is called what? A radical axis of these two circles, and extend it. It will be the angular bisector for this angle. In the same manner, this is what? Radical axis of these two circles, and extend it. This will be the angular bisector for this angle. Now we have drawn three angular bisectors which are meeting at this point. Hence it is incenter. And I have drawn three radical axes for the three circles which are also meeting at P. Hence, incenter of this triangle ABC is the radical center of these three circles. Now let us go to one more point. See here. These three are non-intersecting and non-touching circles. Now, whose centers are taken as ABC. Now connect ABC. So we get here one triangle. Now draw whose radical axis. You know, radical axis is perpendicular to AB. Now, here also perpendicular, here also perpendicular. See students, this is called radical center. Even this radical center is the circumcenter for this ABC triangle. The three circles are non-touching, non-intersecting circles, and connect to whose centers you got a one triangle, and whose circumcenter is the radical center of these three circles. Circumcenter of ABC triangle is coincident with radical center of these three circles. You know how that circumcenter is going to be formed in a triangle ABC. Draw the perpendicular bisectors. of three sides. So which will meet at one point, that is called circumcenter. It is denoted by the letter S, which maintains equidistance from three vertices. Take a radius from S to A and draw one circle. You will get a circumcircle whose radius is capital R, and you know whose positions for various triangles. So for acute angle triangle you will get inside. For right angle triangle you will get midpoint of hypotenuse. Where is the position of circumcenter for right angle triangle? Midpoint of hypotenuse. For obtuse angle triangle you will get outside. Right students, now let us learn one more point here that is not related to this circumcenter, but that model of question is very important in this system of circles. See, two circles will be given to you. One is known as S equal to 0 and one more is S dash equal to 0. One is S equal to 0, one more is S dash equal to 0. This is S dash equal to 0 and this is one more circle. Let us name whose equation is S equal to 0. This dotted circle is bisecting the circumference of S dash is equal to 0. This dotted circle is bisecting the circumference of S dash is equal to 0. Then this common chord will be the diameter for the second circle. If this dotted circle bisects the circumference of second circle, then whose common chord means radical axis is there na, that radical axis will be the diameter for the second circle. Diameter for the second circle. Remember this point. Now let us go to the fourth objective of this chapter, that is length of common tangent, length of common chord. See students, these are two circles whose equations are S equal to 0, S dash equal to 0, and see here which are intersected at two places. Let us name AB. You know students, here we have one formula. That formula now I am going to give you, but before that, that original procedure I explain you how to find this length of common chord. Identify any center, either center of this circle or center of this circle. I am identifying this center. You know how to find center of the first circle and find whose radius. And if you take the difference of these two, you will get this common chord equation and measure this perpendicular distance. Let us say this perpendicular distance is D. You know AB equation you prepared. It is one linear equation in two variables. You may get like this. Now you have center. How to find the perpendicular distance from center to this AB, you know? Use this formula. Mod of ax1 plus by1 plus c by root a square plus b square. You will get D. Now apply the Pythagoras theorem for this APB triangle. So you will get this is r square minus d square. AP length you got. AP equal to PB, no? Hence AB will be 2 into root of r square minus d square units. This procedure you learnt in the circles chapter. But here we have one direct formula to find angle length of this common chord. So that formula I am going to give you. See students. This is S equal to 0 and this is S dash equal to 0. So point of intersections A and B. Now we would have to find this AB length. So identify the center C1, identify the center C2. Now you got a triangle AC1 C2. Now find the area of AC1 C2 triangle. You have many more formulas to find the area of this triangle AC1 C2. So here I am using basic formula 1 by 2 base into height. So here base is C1 C2. In that figure, let us take this base as a D. Let us take this base as D. Length of C1 C2 which is equal to D. And consider this AC1 as radius of first circle. This is the radius of second circle. Now 1 by 2 base into height. Height is here AP. So which is equal to, students, 1 by 2 base into height. You got the area of this triangle AC1 C2. So same area of this triangle AC1 C2 I am going to find by other formula which you learnt in the properties of triangles. See here, ABC is a triangle in which length of BC is small a, length of AC is small b, length of AB is small c. Now area of the triangle delta equal to 1 by 2 product of adjacent sides and sine of included angle. Like 1 by 2 product of adjacent sides, sine of included angle. Now product of adjacent sides and sine of included angle. This formulas you read now. So that formula I am going to apply at this vertical angle. You know this vertical angle 180 minus theta. So now 1 by 2 product of adjacent sides R1 R2 and sine of 180 minus theta. And before that, okay, so prepare one point here. You know, you read this formula cos theta is equal to d square minus r1 square minus r2 square by 2r1 r2. Now in that formula make d as subject. Take this one left side so that you will get d square equal to r1 square plus r2 square plus 2r1 r2 cos theta you will get. When you transfer square that side, d is equal to root of r1 square plus r2 square plus 2r1 r2 cos theta. Prepare it and keep it aside and simplify this. I want to find here length of AB. First I am finding AP length. This I am measuring. So this 1 by 2 you can cancel. Send this D to the right side. So RHS what is left here? R1 R2 sine of 180 minus theta sin theta. When you transfer this D to the right side, so D is nothing but this much no ma. Right here. R1 square plus R2 square plus 2R1 R2 cos theta. So this is AP. But we people have to find here AB length. So in this figure, AB is equal to twice of AP. You know that. Now AB can be written as 2 into this much. 2R1 R2 sin theta whole by root of R1 square plus R2 square plus 2R1 R2 cos theta. So this is the length of common chord AB. 2R1 R2 sin theta by square root of R1 square plus R2 square 2R1 R2 cos theta, where theta is the angle between the circles. Suppose for orthogonal circles, you know theta is 90 degrees. If you put theta 90 degrees here, sin 90 is equal to 1, cos 90 0. Then your AB length will be 2R1 R2 by root of R1 square plus R2 square. I hope you have understood this 4 objectives of the system of circles. Thank you, one and all.